SN1 versus SN2 mechanism. We have learned previously about SN2 and SN1 mechanism. We know that SN2 mechanism prefer methyl halide and primary haloalkane. SN1 mechanism prefers tertiary haloalkane. How about secondary haloalkane? Secondary haloalkane can occur SN2 mechanism or SN1 mechanism. It depends on the factors that determine the mechanism. So, secondary haloalkane or secondary alkyl halide can undergo SN1. It can also undergo SN2 mechanism. Depends on the factors. The factors are types and reactivity of alkyl halide, means we look at the methyl halide, the class methyl halide, primary, secondary or tertiary. So if you want to choose SN1 or SN2, it depends on the class. And then depends on the strength of the nucleophile and other information from the question, such as rate of reaction, because we know that if SN1 mechanism only depends on the haloalkane, is SN2 mechanism, it depends on the haloalkane and nucleophile. So if it's the second order, so it is SN2 mechanism. Okay, and other than that, products form or etc. So these two, SN1, SN2, depends on this factor. Let's look at the strength of nucleophile. In SN1 reaction, nucleophile attacks after the formation of carbocation. Okay, in SN1 form carbocation first and then nucleophile attack the carbocation. So the strength of nucleophile has no effect on the rate of the reaction. Whether it's strong or it is weak, it will still attack the carbocation because the carbon is positively charged. But in SN2, the carbon is C delta plus, slightly positive only. In SN2 reaction, there's no carbocation form. The nucleophile attack the C slightly delta plus straight away. So rate determining step involves nucleophile. Okay, we need to take account the nucleophile concentration. So in SN2, stronger nucleophile has higher rate of reaction. So SN2 reaction prefers stronger nucleophile. If the nucleophile is strong, then SN2 reaction will happen. Okay, so this is the nucleophile. OH minus stronger than H2O, CH3O minus stronger than CH3OH, NH2 minus stronger than NH3. So this CH3O minus is not from CH3OH. This CH3O minus is from CH3ONA. Okay, this is the strong nucleophile. CH3O minus that comes from the CH3ONA. The weak nucleophile is CH3OH, is the weak nucleophile. So this is strong nucleophile NH2 minus, okay, stronger than NH3. Next, we look at the reactivity of haloalkane. So this one, regardless SN1 or SN2, the rate of reaction decreases in order. This is because carbon-halogen bond stronger from iodine to fluorine because electronegativity increases from I to F. So F here, F has the highest electronegativity, means the carbon and fluorine bond is strong. Okay, so the reaction, rate of reaction is slow in here because the carbon fluorine bond is strong. So it's hard to break this bond. Rate of reaction is slower here compared to this one. C and I weaker bond because iodine less electronegative than fluorine. Okay, so that's what it means by rate of reaction decreases down the group 17. Next, class of haloalkane. Okay, so class of haloalkane, if the haloalkane is primary, okay, if it can do rearrangement to become secondary or tertiary, then it prefer SN1. Okay, for primary haloalkane, if you can do rearrangement to become secondary and tertiary, it will prefer SN1 mechanism, because SN2 does not prefer steric effect. It does not prefer the bulky group. So SN1 will happen if the primary haloalkane can undergo rearrangement to form secondary and tertiary. If primary cannot do a rearrangement, then the mechanism for primary haloalkane is SN2 mechanism. That's how you choose which mechanism will occur to that haloalkane, right? And then, if it is secondary haloalkane, I've mentioned previously, secondary haloalkane can occur both, but depends on the condition. So what condition? So if this secondary haloalkane can do rearrangement to become tertiary haloalkane, then it prefer SN1 mechanism, because from secondary to become tertiary, it will become bulky group. It will have bulky group. So SN1 mechanism will be preferred. Form carbocation first, and then nucleophile will attack the carbocation. That is SN1 mechanism. Okay, for secondary. But if that secondary haloalkane cannot do the rearrangement, we look at the nucleophile of the secondary haloalkane. It reacts with which nucleophile? If the secondary haloalkane reacts with weak nucleophile, then it prefers SN1. You have to make the secondary carbocation first, and then the weak nucleophile can attack the carbocation. Because weak nucleophile cannot undergo SN2. Weak nucleophile can only attack carbocation. It cannot attack C delta plus. So that's why if the haloalkane is secondary and it reacts with weak nucleophile, SN1 mechanism will occur. Okay, if the secondary haloalkane it reacts with strong nucleophile, then the strong nucleophile can attack the C delta plus. Okay, because the nucleophile is strong, it can attack C delta plus. SN2 mechanism will occur. Okay, and tertiary, it prefer SN1, bulky. Whether the nucleophile is very strong, it cannot do the backside attack because it's very bulky, so it prefer SN1. Form the carbocation first, and then the nucleophile will attack the C delta, the C plus, okay, the C carbocation. So this is the difference between SN1 and SN2 mechanism. In SN1, rate of reaction is only depends on the concentration of haloalkane, but SN2 will look at the concentration of haloalkane and the nucleophile. Okay, so second order, SN1 first order reaction. Reactivity of haloalkane for SN1, SN1 prefer tertiary haloalkane, and secondary if it can do rearrangement. If it cannot do rearrangement, it maintain the secondary haloalkane, it can undergo SN1 mechanism as well. Okay, it can do SN1 mechanism as well if the nucleophile is weak. But primary and methyl halide does not prefer SN1 mechanism. For SN2 mechanism, SN2 it prefer methyl halide, primary haloalkane, and secondary haloalkane as well. But depends. Secondary haloalkane, it must react with strong nucleophile. Strong nucleophile must be required. And look at the R group in secondary. Make sure it's not too bulky. If it's too bulky, then it needs to undergo SN1 mechanism. And the intermediate SN1, it has carbocation as intermediate, and for SN2, transition state as intermediate. The bond breaking and bond forming occur at the same time. Okay, that's for SN2. And rearrangement may occur to form a stable carbocation. There's no rearrangement because there's no formation of carbocation in SN2 mechanism. That's all for Chapter 7, Haloalkane. Thank you.